Hello grade 11s, in this video I'm going to do another exam question, and just take note that this is an objects in equilibrium or forces in equilibrium exam question. It's got to do with closed vector diagrams, triangle forces, that section of work basically. I'm going to show you two different methods in order to answer this question. Let's jump right in. So the first question is actually a definition, and it says define the term resultant. So a resultant vector is a single vector that has the same effect as two or more vectors added together, okay? Or it's the vector sum of two or more vectors. So that's the definition. I'm not going to write it out because the focus of this video is not on definitions. I've done videos on that in the past. I want to focus on the calculations. So this question is an interesting question. We've got a bucket over here, and they're saying that the grade 11 learners learn that there's more than one way to determine the resultant of two vectors. One way is the component method, and they're going to use this method to find the resultant of the forces acting on the bucket, and they say the bucket is stationary. That over there is our only indication, actually, that this is an equilibrium question, or a forces in equilibrium question. If net is 0 when we have a object in equilibrium. Okay, it's very important. In addition, we also know that our vectors, when rearranged, so our force vectors acting on this object, it'll form a closed vector diagram. In this question, I'm going to focus on the following. I'm not going to focus on the method where we use a closed vector diagram. I'll do that second. What I want to focus is actually what they're asking me in 1.2 and therefore following on to 1.3. They say the tension in rope P is 130 Newton, so they're telling me the size of that, it's 130 Newton, at 30 degrees to the vertical. So this dotted line here is what we call the vertical, and they tell you that at that angle is 30, which we see on the diagram. Tension in Q is 91,92 Newton, so they give me the magnitude of that, at 45 degrees to the vertical, so that is basically that angle. Now look at what the question says. You need to be careful, you need to read the wording very carefully. Calculate the magnitude, now remember magnitude is just the amount or the size, of the resultant, remember resultant is another word for net or overall, of the vertical forces, remember vertical forces go along the y-axis, so those are the up-down forces, exerted by P and Q on the bucket. Okay, that's a lot. They say it's 5 marks, which we know we're going to have to be doing some working out, quite a lot of working out. So again, calculate the magnitude, they just want the size of the net vector of the vertical forces exerted by P and Q on the bucket. So what they want us to do is they want us to look at the situation. We know that P is pulling the bucket upwards like that, up and to the left. Q is pulling the bucket up and to the right. And we should know, or you should know, that the bucket also has a weight associated with it that is pulling down. If I were to draw a free body diagram, my free body diagram will look as follows. This will be the tension in P. This would be the tension in Q, and this would be the weight. Okay, the weight, or you can say FG. It doesn't matter which one you say. Notice, first of all, how I'm saying TP and TQ. You can't just say T and T, because if you label them both T, you're basically telling me that they're the same size. And we know they're not. This one's 130, this one's 91,2. So they need different names. You can also call it F applied P and F applied Q, because the ropes are applying a force. But the thing that I want to mention here is they are specifically asking for the resultant or the overall or the net of the vertical forces exerted by P and Q on the bucket. Now, when they say vertical, grade 11s, they mean up and down. Now, if you look at this diagram, if I have to draw my axes in here, this one would be the y-axis and this one would be the x-axis. Again, when they say vertical forces, they mean along the y-axis, up or down. Now, you guys can tell me, you can pause the video if you need a chance to think about it, which forces out of these three that I drew here act vertically or up or down? You'll tell me weight, and then you're definitely correct because it acts straight down. And then you'll say, okay, that's it. Well, some of you will at least. That's not true, because remember, although tension, this tension in P, that's a 30-degree angle, and this tension in Q, that's a 45-degree angle, they're acting at an angle, which means, I hope you remember what that means. It means that they have X and Y components. So what that means is if I take this and I break it down into its components, it's going to have a vertical component. So this tension over here, this rope, will have a y component, a vertical component. We can call it TPY. And this over here, TQ, will also have a y component. Remember, if a vector acts at an angle, like Q for instance, let's look at Q. Because it's acting at an angle, we know that it has both a horizontal component, let's call that TQX, and a vertical component, TQY. So when we consider the vertical forces, we need to consider all of them, including the components. But again, the question actually doesn't care about weight. It says the magnitude of the resultant of the vertical forces exerted by P and Q. So essentially what 1.2 is asking you to do is it's asking you to break P or TP up into its X and its Y vector. We are only caring about the Y component, and it's asking you to break TQ up into its components, and we only care about the Y component because they say vertical, which means the Y components, and they want the resultant or the overall. So which way do these Y components point? I hope it makes sense to you that the Y component for TP and the Y component for TQ will both point upwards. Think about it. These ropes are pulling the box up and to the left, and this one up and to the right. So the Y components for both will be pointing up, which means what I need to do is I need to work out what the Y component is for this one. I need to work out what the Y component is for this one, and I need to add these two together. That would give me the resultant. Okay, resultant means I must add them up, of the verticals up and down, exerted by P and Q. So let's take it step by step. Let's first find out what the vertical of TP is and what the vertical of TQ is. Now, to keep it nice and simple, what I'm going to do is I'm going to redraw this vector P over here. I'm going to draw it up and to the left, just like it is over here. Remember, they're giving me this angle over here. That's a 30 degrees. If I want to use this angle when breaking it up into the vectors, I do it as follows. Look at that angle. That over there, that vector, this one is P. P is going up and it's going to the left. It's going up and to the left. So which way would its X component go? Its X component would go to the left. So this would be PX, or you can call it TPX. Why am I saying TPX? Because remember, this is a tension force, but just let's keep it PX for simplicity's sake. And remember, this arrow over here, or this P vector, is pulling it up and to the left. So which way will its Y vector go? Well, it'll go up. Look at those two together. So PY and PX, the green dotted line and the red dotted line, together they make up P. I hope you can see that. Now remember, I only care about PY because the question said vertical forces. So how do I find PY? Well, remember, this would be a 90-degree triangle. So between the X and the Y is a 90-degree triangle. P, they gave me the magnitude of P is 130 Newton. So if I'm using this 30 degrees and I look at what my triangle, I have the hypotenuse. Opposite the 90 degrees is the hypotenuse. I have the hypotenuse. I'm looking for PY, which is adjacent to the 30 degrees. And you should know that adjacent is cos. So cos 30 is equal to, what's adjacent to the 30? PY. What is the hypotenuse of this triangle? 130. Again, cos is adjacent over hypotenuse. Adjacent over hypotenuse. The hypotenuse of the triangle is opposite the 90 degrees, which is this line, 130, and adjacent to the 30 degrees is PY. So now how do I solve for PY? You take the 130 over. So it's 130 multiplied by cos 30. And just take note how I'm actually not working out what that is on my calculator. So I've left it as 130 cos 30 newtons. If you wanted to work out what it is on your calculator, you absolutely can. It's 112,5833 ... Do you see how I'm saying ... and I'm telling you that I'm not rounding off? This is not the end of the question, so I cannot round off. So now I've done this for P. This is PY. I now need to do it for Q. I need to find QY. So let's do that quickly. So if you take a look at Q, all I've done is I have redrawn Q over here, so it's nice and big for us to see. They give me 45 degrees. I hope you would agree that Q is going up and to the right. So the X vector would be going to the right, that would be QX, and the Y vector would be going up. Together, up and to the right gives me Q. Look at Q. Q is going up and to the right. Remember, this is a 90 degrees, and we were told in the question that Q has a magnitude of 91,92. 91,92 Newton. Now, remember, I'm trying to find the vertical forces, so I'm trying to find QY. How do I get QY using this 45? Well, I know that Q is 91,92. I know the hypotenuse. Remember, opposite the 90 is the hypotenuse. And I want to use the 45, and I'm looking for QY. If you look carefully, QY is adjacent to the 45. So again, we use cos. Cos 45, cos is adjacent. What's adjacent to the 45? QY. What is my hypotenuse? My hypotenuse is Q, which is 91,92 Newton. Now again, I know that I must take the 91,92 over. I'm going to leave it as 91,92 cos 45 Newton. And what's my direction? It's up as well. I'm not working that out once again because I have not reached a final answer yet. That is not my final answer. But if you wanted to work it out, it would be 64,523,4 and so on. Do not round it off, okay? We are not at our final answer. To go back to the question, remember, we are looking for the magnitude, so the amount of the vertical forces exerted by P and Q. Vertical is my Y forces, so I need PY, I need QY, because they are both pointing up. So remember, PY is pointing up, QY is pointing up, they're pointing in the same direction. So therefore, my resultant in my Y direction, I'm just going to call it RY. You could call it F net Y if you wanted to as well, because it's my net force in my Y direction. That is for P and Q. P and Q. We're going to add them because the question asked for P and Q. Remember, technically, if we want to do F net in the Y direction, we have to include our weight. So let's just say that our answer, let's not give it a name because remember, it's not technically F net in the Y direction because we're not including weight. We would say QY plus PY. So you add those two together. So what I'm going to do is I'm going to add this plus this. And I'm adding them because they're both going up. And what I get when I add them, so here is PY, here is QY, I'm adding them together and I get 177,58 Newton. Remember, the question just wanted the magnitude, which means I don't need to give a direction. But if I were to give a direction, I would say up because remember, PY and QY were both pointing up. So therefore, the sum of them would be pointing up. But they just wanted magnitude, so we're all good. Now, our second question, we want the mass of the bucket. Now, as soon as you see something like this in these sorts of questions, when they ask for mass, the first thing that you should be thinking of is how would I calculate mass if I'm working with forces? Well, remember, I mentioned to you guys that we have multiple forces acting on this bucket. I said we have our tension force that is going up for P. We have our tension force that's going up for Q, and we also have our weight force that's going down. Now, what do you know about weights? How do you calculate weight? If you think about it, you should remember that in order to calculate weights, we say mass times gravity. We're looking for mass. G on Earth is 9.8 meters per second down. So I hope it makes sense to you that in order to find mass, in order to calculate mass, I first need to calculate the weights. Now you might be thinking, ooh, I don't know how to do this. But think about what I told you. Remember, this bucket is in equilibrium, which means that F net, the net force acting on the bucket is 0. And I hope you guys fully understand what that means. What it means is if I take all the forces acting up or down, and I add them together, it'll give me 0 because the bucket is not moving up or down, it's stationary. So F net in the Y direction is 0. What it also means is F net in the X direction is 0. So let's go back to that discussion that we were having earlier on which forces are acting up and down and which forces are acting left and right. If I draw my free body diagram, remember I said weight is acting straight down. We've got the tension in P, like this, and we've got the tension in Q. Now, please, grade 11, think of it like this. Remember, my up-down forces act along the y-axis, and my left-right forces act along the x-axis. I hope you can tell me which forces are acting left and right in this diagram. You can't tell me TP is acting left or right because it's acting up and to the left and up and to the right. So what you'll have to tell me is, yes, ma'am, but remember, we can break this down into its components. So TPX is acting to the left and TQX is acting to the right. And what is important to note, remember we said F net in the X direction is 0. What that means is if I take all my forces acting left or right or along this horizontal axis, if I add them together, it must give me 0. And which two forces are acting left or right? TPX and TQX. If I add those together, TPX plus TQX, together it'll give me 0. And it should make sense. Think about it this way. Let's pretend, we don't know the value, you can work it out, but let's pretend that TPX, you see it's going to the left, let's pretend it's 5 Newton to the left. And TQX is 5 Newton to the right. Let's say they're the same. If they're the same, because one is acting to the right, I will substitute that in as a positive. And because one is acting to the left, I will say minus. What is 5 minus 5? It gives me 0. So what's important to note is that the sum of the forces acting left or right will equal 0, which means in this case, I hope you can see it, that this and this must be the same magnitude but opposite directions. Now in this scenario, it is not so straightforward when looking at my y forces. So let's erase my x forces. Let's just focus on my y forces now. We already briefly spoke about this, but remember, we can break TP up into its x and its y vector. So TPY will be going up and TQY will be going up. They'll both be going up. And what's going down? So this is going up, that's going up. The weight is going down. So what you need to now think about is TPY. So the y component of TP, and TQY, or the y component of TQ, plus the weight. Those 3 yellow ones added together will also give me 0. And the reason why is because the object is in equilibrium. So the net force is 0. Okay, so the x ones added together will give me 0. The y ones added together will give me 0. And that is how we're actually going to end up calculating the mass of the buckets. So what we'll have to do is the following. You start off by saying the F net in the y direction is 0. Then you tell me which forces are acting in the y direction. In other words, which forces are acting up or down, straight up or straight down. You're going to tell me TP in the y direction plus TQ in the y direction plus, what's my third force acting straight up or straight down? My weight. Those 3 together must add up to 0. And now if you can remember from the previous question, we calculated this value over here. We calculated that that value, let's go back over there, is 177,58. There's TQY and TPY. There, we added up together, we got 177,58. So we've already done this part of the calculation. So what I'm telling you is 177,58 plus FG, or the weight, that must add up to 0. So you could say, but ma'am, then FG, if I take that over, the weight is just negative 177,58 newtons. Yes, it is. Now, what does that mean? Remember, what does the negative mean in physics, in science? The negative just tells me the following. It just tells me that the weight is going 177,58 newtons in the opposite direction, which in this case is down. This we substituted in as a positive because it was unspoken, and maybe I should have mentioned it, but I basically chose up as positive. So if up is positive, these two together are going up. So the sum of those, which we worked out in the previous question, the resultant, that will be positive. Leave it as positive FG for now. Now remember, this is not the end of my question. I've got 177.58 newtons down. The negative tells me that it's going down. I know that over here it's a positive, but leave it as a positive because we haven't substituted anything into FG. When we take the 177.58 over, it comes out as a negative, which makes sense because FG is going down, which is in my negative direction. Okay, it won't make sense if you make this a negative and then take that over and it becomes a negative. It's just going to confuse you. So if your answer comes out as a negative, which mine does, it means it's going in the negative direction, which is down. That's not the end of my question. Remember, my question wanted mass. I just worked out the weight, but we discussed how to get from my weight to my mass. You write your formula. That is my weight. So that goes over there. 177.58. My mass is what I'm looking for. G is 9.8 meters per second downwards. To solve for my mass, I take this and I divide it by this. So 177.58 divided by 9.8. And you should get an answer of 18.12 kilograms. Now, just please take note that in the previous question, so 1.2, remember that was where I got this answer of 177.58. You can, however, keep this to more decimal places. You're allowed. The rule is at least 2 decimal places, but you can keep this to 3 or 4 or 5 or 6 or however many you want. If you then use that full answer, that 177.58 in the next one, you might end up getting a slightly different answer. We will have to accept both. But because this is a new question, you may also use the rounded off version over here when you substitute it in. Now I'm just going to very quickly show you another method to get to this answer. So say the question didn't ask for the first one. Let's say it didn't ask for 1.2. Okay, so we didn't have to work out TPX and TQX. Let's say they just wanted mass, straight up just wanted mass. Another way that you could have done this is you could have used a closed vector diagram. Now remember how that works is as follows. You are going to take your vectors. So we know we have a weight vector, we have TP and we have TQ, and we're going to rearrange those vectors into a closed triangle. So let's start with weight. Weight goes straight down. Then I'm going to do TQ. Now look at which way TQ is pointing. TQ is pointing up and to the right. So I'm going to go up and to the right like that. There's my TQ. And I'm just going to label it TQ, or you can just call it Q, it's fine. And then we've got P, and P is pulling up and to the left. So that would go like that. That would be TQ. It's better to say T because we know it's a tension force. Now be careful here with the angles. Take a look very carefully at what we have over here. If I have to draw in a vertical, so remember the vertical, it's basically like the weight vector. It's along the y-axis. The angle between the vertical and this Q vector over here is 45. So between the vertical, this is basically a vertical, and TQ over here, that vector is 45. That angle over there, sorry, is 45. Then, how I found this angle over here is as follows. This angle over here is basically if I have to draw in a vertical over here. Here's my vertical. It's this angle over here. Now, how do I find that? There's lots of different ways to do it. One way is, remember this and this, these are both verticals, so they're parallel to each other. So you could use alternate angles. Hope you remember alternate angles from geometry. So if that's 30, then this angle here, which is this angle here, is also 30 degrees. Another way to do it is if you create your own little triangles. So if this one here is 30, this one over here is 90, this angle over here must be 60 because I'm looking at this little triangle, angle sum triangle. If this angle is 60, this one over here must be 30, which is that angle over there. Once you've got your angles, two of them, you can find this third angle by using angle sum triangle. 180 minus 30 minus 45, I get 105 degrees. This is not easy to do, figuring out the angles. So if you're struggling with this, you're going to have to go watch previous videos in my playlist because I obviously did go over this pretty quickly. But you have to look at the way in which the angles and the vectors are orientated. So the 45 was easy because it's at the base of Q, you know, in between the base of Q and a vertical. This is a vertical. W is basically a vertical because we know it goes straight down, and here's the base of Q. So that's 45. The 30 was, I think it was fine, it was okay to find because I know that it is basically this angle here underneath P. So it's this angle over here. And if this is 30, this has to be 30 because of alt angles. I think that's the easiest way to see it. And then once you find two of them, you can find the third one. But now how is this going to help me find my weight? Because remember, we're trying to find mass. And in order to find mass, we must find weight first, because weight is mass times gravitational acceleration. So if I'm looking for mass and I have G is 9.8, if I know weight, I'm good to go. But how do I find weight? Weight is over here. Do I know any of these other forces? I do. They gave it to me. This one is 130 Newton, and this one over here is 91.25 Newton. So some of my students say to me, but ma'am, can't we just do Pythagoras because we know two of the lengths? No, we can't, because it's not a 90-degree triangle. We also can't do our normal trig ratios, which is sine theta, cos theta, tan theta, because it's not a 90-degree triangle. But in the previous video, I showed you how to use the sine rule. If you missed that video, I explained it in some detail in that video, but we learned how to use the sine rule in order to find a missing length. So we don't have to have a 90-degree triangle in order to do the sine rule. And that is basically what I've done over here. So how the sine rule works is I take the side that I'm looking for. So I'm looking for W. And I divide it by the sine of the angle opposite W. So I'm looking for W. I divide it by sine 105. So W divided by sine, is it 105? 105, yes. And I make that equal to a fraction where I know the length of the side and the angle. So what I mean is I know 130. Okay, cool. So I know that length of the side. And I divide that by the sine of the angle opposite 130. So here's 130. It's that arrow over there. Here's the angle opposite 130, 45. So I divide it by sine 45. And when you solve for this, I go into more detail if you're struggling. 130 divided by sine 45, multiply by sine 105. And when I do that, I get my weights to be 177,58 ... so on. That is exactly what we got when we used the other method. Now I'm going to take that entire number, 177,58. I'm not going to round it off. Mass is what I'm looking for. G is 9.8. So I'm going to take that long number, divide it by 9.8 because I'm looking for mass. It's times 9.8 over here. So when you take the 9.8 over, it becomes divide. And I get 18.12 kilograms. That is exactly what I got when I used my other method. I hope you remember 18.12. That was the first method. And when I did the other method, I got the exact same answer, 18.12 kilograms. So what I'm trying to show you grade 11th is there's different ways to do this. If you like the sine rule way, you may not have been taught it because you only learn the sine rule later on in grade 11. But it's a helpful method. If it makes more sense to you, if it's easier, if it's quicker, if it's shorter, I don't see an issue with you doing it. You may just want to check with your teacher if she's okay or he's okay with you doing it. But I hope that's been helpful for you. If you've missed any other vector videos, I go over other exam questions in this playlist. Just click the link in the description box below. And I hope to see you in another video. Bye, everybody.